Hi students, in this video we will be seeing the drift velocity expression, the mobility expression, the resistivity expression as well as the vector form of the Ohm's law. In the end of the video, I will be explaining a very interesting fact about current electricity, so please watch till the end. If you have not yet subscribed to Easy Exam Academy channel, please do subscribe and click on the bell icon for more updates. Let's get started. What is drift velocity? Inside the metal, the presence of free electrons is what it is making it as a conductor. The free electrons will be moving like gas molecules freely inside the conductor. In normal conditions, the average velocity of all the free electrons is 0 because of the random motion. Velocity is a vector quantity, so one electron will go like this and another electron will go like this. So vectorially, if you add all the electrons, it will be 0. But once when we connect the conductor to a battery, or once the electric field is set up inside the conductor, the electrons will start moving in the opposite direction. The electrons will experience a force that is equal to Q into E and start accelerating in the opposite direction of the electric field because of the negative charge. When a single electron starts to accelerate, it will collide with the other electrons and it will lose some of its energy. Some electrons will be colliding in very short interval of time and some electrons will be colliding after some long interval of time. The average time of collision, the average time interval between the collisions is called as the relaxation time. Relaxation time is given by the letter tau. Let us say this is the electric field and the electron is kept here. The electron will experience a force and it will start to accelerate like this in this direction. F is equal to Q into E. M into A is equal to E into E. So the acceleration of the electron is E divided by M, which is negative. So for single electron, at any instant, I can write T1 minus T2 is the Ti, which is the collision interval. That means the time taken for the electron to collide with the another electron. So I can write Vi is equal to Ui minus A into Ti for a single electron. This is the equation of the motion. V is equal to U plus AT, S is equal to UT plus half AT square. V square minus U square is equal to 2AS, that we have studied in the kinematics 1 dimension in the 11th standard. So some of the electrons will collide immediately. That means that T2 minus T1 is small, whereas some electrons will collide after some long time. So T2 minus T1 will be large. So the average time between these collisions is called as the relaxation time, that is tau. So when I am representing the average velocity, I need to write V average is equal to U average minus acceleration into relaxation time, considering all the electrons together. We know that U average is equal to 0 because of the random motion of the electrons that I have discussed earlier. So V average is equal to minus acceleration is E by M into tau. So this is the expression for the drift velocity. The drift velocity is very small. It is in the order of the 1 millimeter second or 10 millimeter per second. Now let us proceed to derive the expressions for the mobility, resistivity and the vector form of the Ohm's law. Let us consider a cross-section area of the conductor as shown in the figure. When an electron is moving from this end to this end for delta time interval, the electron will cover a distance of delta x. We know that the speed is equal to distance divided by time and delta x is equal to drift velocity into the delta t. Now let us define small n, which is the number of electrons per unit volume of the conductor. I can write total electron in this area. Total electron is equal to n into volume. What is the volume of this cross section? That is equal to n into area of cross section into length. Volume can be represented as area into length. So that can be written as N into A into Vd into delta T. So the total electrons is small n into A into Vd into delta T. So what is the total charge? Total charge is equal to charge of each electron, that is E into the total electron. So the total charge Q is equal to NEA Vd into delta T. We know that current is equal to charge divided by delta T. So the current I is equal to NEAVD delta T divided by delta T. So the current is equal to NEAVD, which is very, very important formula. Now consider I divided by A, which is equal to N into E into Vd. We know that Vd is equal to EE by M into tau. I by A is called as the current density, which is represented as J. So J is equal to N E square tau by M into E. This expression is called as J is equal to sigma E, which is called vector form of Ohm's law. This expression is called the vector form of Ohm's law, and sigma is called as the conductivity. So rho, resistivity, is equal to 1 by sigma. So the resistivity of the conductor that we use to calculate the R is equal to rho L by A is given by M divided by N into E square into tau, which is another important formula. The mobility of an electron is defined as mu equal to drift velocity divided by the electric field. So the mobility is given by EE by M into tau divided by E. So I can write mobility of the electron is equal to E by M into tau, which is another important formula that you need to remember. So combining these both formulas, rho is equal to M by E tau into 1 by Ne, which can be written as rho is equal to 1 by Ne into mu. This is another expression of resistivity in the terms of mobility. So in this video, we have seen the derivation of drift velocity, the vector form of the Ohm's law, mobility expression, resistivity expression, and the relationship between mobility as well as the resistivity. One interesting fact that you need to observe is whenever I turn on a switch, immediately the light or the fan is working. If the drift velocity is in the order of 10 millimeter per second, then the current will take infinite time to go to that fan or light. In reality, why it is lightning fast? Because it is the electrical energy that moves and makes the bulb or the fan on, not the each and every electron that is coming from the battery to the light or fan. So one electron will go with drift velocity and transfer the energy to another electron. That electron will collide with another electron, and it happens like kind of a domino effect. This domino effect kind of energy transfer is in the speed of the light. So that is why whenever I switch on the switch, immediately the bulb or the fan will work. So thank you for watching this video. If you like this video, put a thumbs up and share this video with your friends. If you have any doubts, please feel free to leave in the comment section. Thank you.